Next problem is probability. There are two players, A and B. Suppose probability of A winning is small p and probability of B winning is small q. Okay, and there is no other possible case. Draw is not available, so p plus q is equal to 1, and it is given that p is greater than q. P is a better, A is a better player, and probability of A winning is higher than probability of B winning. B comes to you. So now B has been given option of choosing. B is given option of choosing whether to play best of 1 or best of 3. What do I mean by that? You play one match and the result is declared final, or you play 3 matches, one after the other. And depending upon best of 3 means the one who will win 2 is the winner. Okay, that is called best of 3. And best of 1 is you play only one match, whoever is the winner is the final winner. Okay, so B is given the option to choose whether to select the format of the match, best of 1 or best of 3. Okay, so if you are consultant to B, what will you advise? What is your advice? ADVIC advice. Have you understood the question? Now, if there is one match, then calculations are easy. Probability of A winning the one match is higher than probability of B winning the first match. Okay. Now we will have to find out whether the probability of B winning best of 3 is more or not. That is what we want to find out. Therefore, we need to analyze best of 3. So, probability of, let us define event A3, best of 3, probability of 3 matches and A is winning. Okay, so probability of A3 we have to find out. Probability of, if it is best of 1 match, probability of A winning if it is best of 1 match is P, which is greater than Q, which is known to us. So if we find out probability of A3, that means probability of A winning in best of 3 matches, and if we compare these two, then we will be able to decide properly. Now if A is winning, then A can win in following different ways: win, 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 all 3. And suppose for calculation purpose all 3 matches are played, you can, of course, if 2 matches are won by A, you need not have to play the third, but for our symmetry of calculations, let us do all 3 matches are played. So W, W, L, W, L, W. then L W W. This is two W's and one L is over. Now W L L W, sorry, L W L, second place L L W, and last is L L L. These are the eight possible ways: first match, second match, and third match. Correct. So now let us do our calculations. We are trying to find out probability of A winning the tournament in best of three type of formats. So as far as A is concerned, win. So probability of A winning first match is P, and second match is, and third match is P, which is PQ. Therefore, this is PQ. Or means plus. First match is P, second match is P, third match is Q. P square Q plus P square Q plus P square Q. Up to this point is over. Then plus PQ square. Now I am just, ignore this plus sign, I am just counting for the first time. Then we will see which ones to add. First one is probability is P cube, second is P square Q, third is P square Q, fourth is P square Q, fifth is PQ square, PQ square, PQ square, Q cube. If you add all of them, we will get P cube plus 3P square Q plus 3P Q square plus Q cube is equal to P plus Q bracket cube is equal to 1. So it is correct. All the probabilities should add up to 1, which is happening. Now, probability of A winning in 3 matches is P cube plus 3P square cube. Only up to this. Beyond this, A is not winning. So now we will have to compare whether P cube plus 3P square Q is bigger, question mark, than P or not. So if it is bigger, then probability of A winning in 3 matches is higher compared to in 1 match. So we should advise B to go for only 1 match. But if PA3 is smaller than small p, then we should advise B to go for 3 matches. Do you understand the comparison? Now we wish to compare this with this, given P is greater than Q. So how are we going to do this? Question mark. Okay. So you can take out P common, which gets cancelled. So P square plus 3PQ. Is it greater than question mark P? So P is non-negative, therefore you can always cancel it. So now this is algebra. This is algebra, you are comparing two numbers. So P square plus 3PQ. Is this greater than question mark 1? Now 1 can be written as P plus Q. So one more P is getting cancelled. So P plus 3Q. Is it greater than Q? So P plus 2Q. Is it greater than 0? Correct, Challe? 1Q is getting cancelled from.
Should be 1 plus Q by P.
P square. So P plus 3Q. Is it greater than 9? Something wrong I did. Very poor algebra. This is P plus Q. So what should I do now? P plus Q is 1. Now I am supposed to compare. So let me take P square upon p square plus 3pq upon p plus q. Is it greater than question mark 1?
सर ते 1 ला p plus q square लिहायला.
हा इथे स्क्वेअर करूया. ओके, दॅट इज गुड. That is not bad idea. We want to get rid of square, so we square this, which is equal to p square plus 2pq plus q square. Okay, so p square gets cancelled. You get 3pq question mark q inside bracket 2p plus q, correct? Q gets cancelled, therefore 3p is it question mark p plus q is 1, so this is p. परत चुकलं काहीतरी, बरोबर आहे ना? आता q कॅन्सल, 3p 2 प्लस p प्लस q प्लस p प्लस 1 नाही ते नाही. हा, yes, so 2p is greater than 1, p is greater than half. Oh, this is true, therefore this is true, first one is true, and hence probability of a3 winning in 3 matches is greater than probability of a1, hence advice best of 1 for b. Okay, okay, next is either best of 3 or best of 5. What advice will you give to player B based on your calculations, based on your probabilistic calculation? For best of 3 and best of 5, what we need to compare is P A5 versus PA3, probability of A winning 3 matches compared to probability of A winning in 5 matches, which is, now we understand those calculations, P raised to 5 plus 5 P fourth Q plus 10 P cube Q. That is these are the different ways that in 5 match series A will win, adding all those probabilities, and in 3 it will be P cube plus 3P square Q plus, that's all. Okay, now we have to compare this. Numerator is 5th degree.
It should be p cube q square, right?
Sorry?
P cube q square, right? And the numerator.
Here?
Also in the numerator, 10 p cube q square.
Here. Yes. So if we want to compare this ratio, numerator is degree 5, therefore we make denominator also degree 5. Okay. Then try to arrange them. 5p fourth q plus 10p cube q square. Okay. Divided by, let us multiply p fifth, then 2p square, 2p fourth q plus 3p fourth q, that is 5p fourth q, plus p cube q square 1 and 6 p cube q square 6 and 1 7 p cube q square. Okay, plus p square cube 3 p square q cube, and that's all, 3p square q cube. That is the only term which is remaining. So is this done? Multiplication, this into this first term, then this has got two terms, 3, 4, 5 and 6, total 6 terms, correct. Okay, so out of this numerator now, p raised to 5 plus 5p raised to 4q plus 7p cube q square plus 3p cube q square, that is 10p cube q square in the numerator, p5 plus 5p fourth cube plus 7p cube q square plus 3p square q cube. Now all these three terms are same, so the fraction will be greater than 1 if this is bigger than this. Is that right? So we compare 3p cube q square upon 3p square q cube. 3 gone, p square gone. So we get p upon q directly. So we compare p upon q, which is greater than 1. Therefore, probability of A winning in 5 matches is more than probability of A winning in 3 matches. Therefore, advice for best of 3. Simple. Right? Understood? समझ ले सके ना? Okay, next question is, team A has probability of winning 0.6 and B has probability of winning 0.4. Best of 7 matches is to be played. After first match, the score is 1-0. A is 1, B is 0. After 3 matches, score is 2-1. Probabilistically, should team B be happy after 3 matches compared to after first match or not? Do probability calculations and tell me the answer. Okay, so the way we had done calculations in the last problem, same notation, probability of, let us find out probability of B winning in remaining 6 games. How much is this? Q raised to 6 plus 6 choose 1, that is 6, Q raised to 5 P plus 6 choose 2, that is 15, Q raised to 4 P square. Correct? They must get 4 wins na total. Q should win remaining 6 matches out of 7 because 1 is lost, or 5 matches or 4 matches in the remaining 6 matches. So this is the probability of Q winning more than 4 matches after first game match is over, and probability of B winning remaining matches are 4. In the remaining 4 matches, Q raised to 4 plus 4 choose 1, 4 Q raised to 3P. Either they should win 3 more matches or they should win remaining 4 matches. So this is what is the probability of B winning the tournament by winning 4 matches overall. That means 3 matches after the 4 matches after the 3 matches, or 6 matches after the first match. So we have to compare these two results, and we will compare it exactly the same way. Take the ratio. Now you can see that Q4 is coming out common, so it will go disappear, and therefore the terms remaining will be Q raised to 2 plus 6Q P plus 15p square. That is what is in the numerator. Q cube has gone with the numerator q4. So 1q is remaining inside bracket. Q fourth, q is remaining. Q cube common. So q नहीं बरोबर चल रहे हैं. In the numerator we have q fourth common, in the denominator we have q cube common. So in the numerator we have q, and in the denominator we have q plus 4p. I hope this is correct. So in the degree of numerator is 3, q cube plus 6q square p plus 15 qp square. Let us make degree of denominator also 3 by multiplying it with q square plus 2qp plus p square. Okay, that makes it q cube. How many q square p's? 4 plus 2, 6q square p's plus how many qp squares? Qp square, 1 here and 8 here. 8 plus 1, 9 qp square, 9 qp square, and then how many p4? P cube, 4p cube. Okay. So finally the comparison is going to be, now let us write the numerator as 9 plus 6. So 6 q p square and 4 p cube. Is that right? That is what we want to compare. We have to compare these two. 9 we removed from 15. We got 6 q p square in the numerator extra, and in the denominator we have 4 p cube. Everything else is same. So we need to compare this. And now maybe we have to use okay, so this is the time when we should put values. 6 into 0 0.4 into 0 0.6 and 6 upon 4 into 0 0.6 into 0 0.6 into 0 0.6, and you will observe that this is equal to 1, which means probabilistically team B has chances of winning tournament exactly same as that of after 1 game and 3 games. It is 1 and C. A and B keep playing. Whoever wins the first game wins the match. This is the rule of the match. Probability of A winning the chess game is P, probability of B winning the chess game is Q, and probability of remaining draw is R. P plus Q plus R is equal to 1. The match is over the moment any one of them wins the first game. First game. This is important. Any one of them wins the first game. Suppose they play against each other in the first game itself. Suppose A wins, the match is over. But suppose A is draw, second game they will play, again it is draw, third, and they will continue till somebody or the other wins. Then what is the probability that A wins the match? Now you never know how many matches draw are going to take place before A wins the first match. It could be 0, it could be 1, it could be 2. How many matches are draw? So you can add all of them, and R happens to be less than 1 positive number. Therefore, you know the summation of those R's, and you can quickly arrive at the probability of A winning the match P upon P plus Q. Okay, but then second level problem is little different. Probability of, okay, the rules are changed. A and B keep playing, that is correct. Whoever wins two games, first two games, wins the match. Okay, this is the rule of the game. Now find the probability of A winning. So let us write this event as probability of A winning after, this was P E1, after 1, and first match is 1, first game is 1, match is 1. Here probability of A winning by winning two games. I mean those two games need not be consecutive. They can be win, after that 5 draws and then win. Win, after that 1 lose, after that 5 draws and then win. Anything is okay. Probability of A winning this type of tournament is either case 1, A wins without losing a game. Okay, so suppose A wins without losing a game, sub case of that could be win-win in the first two, or draw, win, win, or draw, win, win, or it could be draw, win, something like this. Is that right? So how have you added this? So it is going to be P square P square is going to be probability of winning two games, and then number of draws. Yes, tell me what is your method, because my method is little complicated. So if he wins without losing a game, WW, then it is P square. Then second case it will be plus P square R. That will be 3 times. Is that right? 3 P square R plus. Then he wins P square by having 2 D's. And then in how many ways I can put 2 D's in this? It's a repetition, a permutation with repetition, something like that. So what will be the coefficient here? 4 factorial upon 2 factorial into 2 factorial. What was
सर 3p स्क्वेअर आर नाही होणार ना, कारण विन विन ड्रॉ ही सिच्युएशन आपण नाही घेऊ शकत.
win-win?
सर विन विन ड्रॉ ही सिच्युएशन नाही घेऊ शकत ना, मग 3 कसं आहे?
Sorry, 3 नाही होणार ते. 4 factorial upon 2 factorial. बरोबर ना? 2 win and 1 draw. In how many ways we can have 2 win and 1 draw? नहीं, first, अच्छा. So how are we going to do it without losing a game? Okay, why should we consider this? We should consider he makes it by losing 0 games, or he makes it by losing 1 game, or he makes it by losing drawing 2 games, or 3 games, or 4 games, and so on. Is this going to be like that? I mean, r square, 1 plus r square plus r cube plus r fourth. Is this the summation of probability of E winning without losing? I think so. P square upon 1 minus I. Okay, one way of solving this problem is to really count how many draws are there and take accounting of that draws also, and eventually you want two wins without losing a game and with losing a game. Therefore, there will be two different calculations which you do, and eventually you get the probability of a winning by winning two matches. Okay, and the answer is going to be looking like this. But the easier way of doing it is consider three cases. A wins without losing a match, which is win after win. And there could be draws before or in between, but you need not have to worry about draw. Once one match is win, it is W, another match is win, it is W. So the first case, we know, I mean, if you consider these two wins as the answers for the previous problem, what is the probability that A wins the first match? It is P upon B plus Q. And then suppose that problem is over and a new problem starts. What is the probability of A winning actually second match, but then we consider it as a first match only because we reset, and the probability is P upon B plus Q. Therefore, P upon B plus Q bracket square is probability of A winning two matches without losing. Now, if suppose A is losing one match before winning the second, then there are two cases: win, loss, win, or loss, win, win. And in either case, you will get P upon B plus Q bracket square because you require to win twice. And there will be one loss, which is Q upon Q plus P plus Q. And hence, probability of two winning without losing a match is this. Probability of winning by losing one match is this. Add them, you get the desired answer. Okay, this is shorter method. Maybe I will explain you the longer method also, but let me get that on the board while you are solving the other problem. Okay, next problem. Next question is, a circle is drawn of radius r and a chord is drawn at random. E is the event such that the length of chord is greater than or equal to root 3r. Find the probability of E. Okay, so if you consider a circle and take one point over here, then join this, and then your 120-degree arc, if you make like this symmetric, then every second point you choose over here, this is your A, and you choose B anywhere here. If you choose B at the end point here, it will be exactly root 3, which is acceptable. End point exactly root 3, and therefore you want to draw a chord something like this, which is going to be greater than root 3. So favorable is this arc. Total is the circumference of the circle, which is 1/3. Good. That is one way of looking at it. Now there are more than 3 answers that are being given. The logic for the first answer, which is 1/3, is the angle at the center, if it is 120 degrees, and if you fix a point, one end point of the chord on the circle, the second favorable arc is 1/3 of the total circle, and therefore probability is 1. So first answer is 1/3. Second answer, if you consider a circle with radius r and another circle of radius r by 2, one inside the other, and if you consider the midpoint of the chord, then favorable, the midpoint is in the interior of smaller circle, the chord will have length greater than root 3r. So favorable area is area of smaller circle and total area is area of outer circle. So pi r by 2 bracket square upon pi r square becomes 1 by 4 probability for this type of setup. The third way of looking at it is you draw a diameter and consider all chords perpendicular to that diameter. Then such that the midpoints are on the diameter. I mean, if you are considering perpendicular, midpoints will be on these diameters. Now, those chords which have their midpoints between between r by 2 to r by 2 from center will have length more than root 3 by more than root 3 r. So that is our favorable. So favorable is capital R and total is the diameter 2r, and therefore probability is half. Probability was 1/4. Probability is 1/3. So this is the first time we are getting different answers for the same question, and essentially it is happening because we are dealing with randomness of the event and the definition of the event. Every time the definition of the event is different and probability is going to depend on your definition of that event. That is reason number 1. And reason number 2 is, in either case, in every problem that we have discussed, every solution that we have discussed, in every case there were infinitely many favorable chords and infinitely many total chords. So when it comes to infinite upon infinite, things are going to be little different. That is what we are experiencing right now. So all answers are correct. We cannot say that this answer is correct and that answer is wrong. All answers are correct. So this is typically because of the randomness of the experiment that you are defining, and you are dealing with infinitely many favorables and infinitely many totals. There can be some efforts which can be made where whatever probability that you want can be achieved. An experiment can be designed by which whatever probability that you want can be achieved. That is your thinking. Otherwise, this is very interesting problem in probability, where whatever answer you give, your logic is different, reasoning is different, but answer is correct. Okay. Okay, tomorrow we will solve this problem considering the draws also and do the calculations and check whether we get the same answer. Okay, remind me in the beginning of next lecture. Thank you.